Okay, we're going to continue on here with Chapter 11, Section 3 on motion and forces. So let's get to key ideas here. What do scientists identify as the fundamental forces of nature? We'll talk about the fundamental forces, what they are. There's four of those. What happens when there is a net force acting on an object, and what force always opposes motion, and then why is friction sometimes necessary for us? So we'll skip this bell ringer here. So the fundamental forces. These forces are the force of gravity, electromagnetic force, strong nuclear force, and a weak nuclear force. Those are your four fundamental forces of nature. So make sure you have that understood. Force of gravity, which is what keeps us on the earth. Electromagnetic force, which is the forces due to like positive and negative charges that attract or repel each other. Then strong nuclear force and weak nuclear force have to deal with things on the atomic scale. So strong and weak nuclear forces act only over on short distance, like I said, on the atomic scale, so down around the atom. Those are distances the strong and weak nuclear force act on. Force of gravity, of course, keeps you on the earth. It keeps you from floating away. And then other everyday forces such as friction are a result of things like the electromagnetic force or other things. Okay, fundamental forces vary in strength, very widely in strength, and the distance over which they act. They can act through contact, which is direct physical contact, or over distances like gravity. If you jump off of something, you're not in contact with the earth, but it still pulls on you. That's why you accelerate toward the earth. Pushes and pulls are examples of contact forces. You have to actually have physical contact for you to push or pull something. Field forces, that's like gravity, do not require that objects touch each other. They can act in a field where you feel the force, but you're not necessarily in contact with the object that's creating that force. Both contact and field forces can cause an object to move or stop moving. So balanced and unbalanced forces. So what happens when there is a net force acting on an object? So whenever there's a net force acting on an object, the object accelerates in the direction of that net force. And to define net force, it's the combination of all the forces acting on an object. When you have an object that will have stuff like gravity, excuse me, like gravity pulling on you. Maybe if you're sitting in a chair pushing back upwards on you to keep you from falling. Then if somebody's pushing you, when you take all those three forces together, the net force that's left, and usually if gravity's pulling on you and the chair's pushing up on you and you're not going up or down in that chair, those two kind of cancel each other out, and the net force that's left is that one force that's pushing you. Alright, so balanced forces generally do not change motion. Like I said, if you're sitting in a chair and you're still, forces there are balanced. Gravity's still acting on you, but the chair is also pushing up on you with the same force that gravity's pulling down on you with. So those forces are equal and opposite, so they're balanced. Your motion doesn't change. Forces are balanced when that net force is zero. Here the example for a light hanging from a ceiling, which the light's at rest, it's not moving up or down. Upward force is due to tension in the cord, balances gravity pulling the light down, so it stays still. Unbalanced forces don't cancel completely. That's like, again, if you have sitting in a chair, maybe in a rolling chair, where you're sitting, gravity's pulling you down, but the chair's pushing you back up, so you're not moving down, you're not moving up, but then somebody pushes you from the side. That's an unbalanced force because all of those forces together don't cancel out completely. So when forces are unbalanced, when the net force is greater than zero, object will accelerate in that direction, just like if somebody's pushing you in that roller chair. And it gives an example here. If you push a box to the east, your friend pushes a box to the north, box is actually going to accelerate and kind of go in between those two at an angle and in like a northeasterly direction. So you have a force going one way and a force going the other. They don't cancel each other out because they're not equal and opposite but those two together give you kind of one force that the box feels in this case, which is the northeastern force. Okay, so let's watch this little video here.
To move a piano, one of these students is pushing it and the other is pulling it. Each student is exerting a force on the piano. To move a piano, one of these students is pushing it and the other is pulling it. Each student is exerting a force on the piano. A force has both magnitude and direction. It is measured in units of newtons. The student on the left is exerting a force of 25 newtons to the right. The student on the right is exerting a force of 20 newtons also to the right. Together, the students are exerting a net force on the piano. This net force is an unbalanced force on the piano and causes the piano to move to the right. An unbalanced force is always necessary to move an object from rest. An unbalanced force is also necessary to change the motion of an object that is already moving. Balanced forces cause no change in the motion of an object, whether it is moving or at rest.
Alright, so let's move on here. Next one, force of friction. So what force always opposes motion? Force of friction always goes against the direction of motion. So force that opposes motion between two surfaces that are in contact, and that's what you have to have with friction, is two surfaces that are in contact, like a box sliding on the floor. So there's two kinds of friction. You got static friction and kinetic friction. Static friction is always greater than kinetic friction, and static just means that itself it's still, it's not moving. That's the force that resists the initiation of sliding motion. That's the force that you have to overcome to get something moving. Like if you're trying to push a big box and you're pushing and pushing and pushing, that's all static friction that's keeping it from moving. And then as soon as it breaks and you start, that box starts sliding as you're pushing it, that's when it goes into kinetic friction. So static friction, force that resists the initiation of sliding motion between two surfaces that are in contact and at rest. They're not moving yet. Kinetic friction is the force that opposes the movement of those two surfaces. That's once you've got it sliding, kinetic friction, and that's less than what static friction is. So let's listen to this one.
There are two kinds of friction forces, static and kinetic. Static friction is a resistive force that opposes the relative motion of two surfaces in contact that are at rest with respect to one another. When you try to push an object along a surface, you will experience the macroscopic effect caused by a complex combination of forces at the microscopic level. As long as the object does not move, the force of static friction is always equal to and opposite in direction to the component of the force you apply that is parallel to the surface. If you observe carefully, you will notice that you need a smaller force once the object has started to move. This is the kinetic friction between the surfaces. Kinetic friction is the resistive force that opposes the relative motion of two contacting surfaces that are moving past one another. Kinetic friction is always less than static friction, but both have the same direction. They are always opposite in direction to the component of the applied force that is parallel to the surface of contact.
Okay, so let's move on here. Not all kinetic friction is the same. Sliding friction when objects slide past each other. Then you have rolling friction when a rounded object rolls over a flat surface. That's still kind of considered kinetic friction because it is in motion. And in general, rolling friction is less than sliding friction. Alright, so let's look at a few concept types here.
Static friction is the friction that exists when a force is applied to an object before the object begins to move. Once the object is in motion, the friction can be characterized based on the conditions under which it is occurring. Sliding friction occurs when you push a large, heavy object across the floor. Sliding friction is highly effective at opposing the movement of objects. Brake systems, such as the one on this bicycle, frequently use sliding friction to slow things down. When an object is placed on wheels, the resulting friction is rolling friction. If both surfaces are hard, the force of rolling friction is usually less than the force of sliding friction. Because of this, most land transportation involves the use of wheels, as seen in cars, trucks, and trains. Fluid friction occurs when one of the surfaces in question is a fluid, such as water or air. Wet floors, for example, are slippery. Fluid friction is considerably less than the usual sliding friction that helps keep your feet in firm contact with the ground. Lubricants such as oil and grease take advantage of fluid friction to keep things moving smoothly and reduce wear. Without oil, engine parts quickly become worn and damaged.
Alright, so let's keep moving on here. So why is friction sometimes necessary? It's necessary for many of the stuff we do, all of our tasks throughout the day. Unwanted friction, can be lowered using low friction materials such as non-stick coatings, cooking pans, lubricants such as motor oil, wax, grease. Helpful friction, we can increase helpful friction. You can scatter sand on an icy road to keep cars from skidding. You can wear textured batting gloves when you're playing baseball. It makes it easier to grip that bat. Alright, and ways to reduce or increase friction here. Let's listen to this one.
Friction can be harmful. Friction between moving car parts causes them to heat up and wear out faster. Lubricants can be used to reduce the friction. Some examples of lubricants are motor oil, wax, and grease. Graphite can also be used as a lubricant for skate wheels and ball bearings. Friction can also be helpful. Without friction, you would not be able to walk because you would slip. One way to increase friction is to make surfaces rougher. Soccer players wear shoes with cleats to increase the friction between their feet and the ground. Another way to increase friction is to increase the force pushing the two objects together. Pushing harder on the scrubber will increase the friction between the scrubber and the pan. Added friction will help clean the pan faster.
Okay, so let's move on here. Cars couldn't move without friction. Your tires are in contact with the road. They are rubber for a reason. It has a better friction coefficient, so they can get traction better on the road. And without friction, the tires between the tires and the road, tires wouldn't be able to push against the road and move your car forward. And the force pushing the car forward must be greater than the force of friction that opposes the car's motion. And because of friction, a constant force must be applied to a car just to keep it moving at the same speed. That's why you have to keep your foot on the accelerators. There's always friction going on in the engine and all the parts going to the wheels in the ground, moving. All those things have friction, so you constantly have to apply force to be able to overcome that friction. So friction and motion here, you got several instances. When a car moves at constant speeds, force moving the car forward exactly balances friction. So in this case, you have a constant speed and balanced forces. Or when you have balanced forces, you have a constant speed. When a car accelerates, force of the car moving forward is greater than the opposing force of friction. So in this particular case, you have acceleration. When you have unbalanced forces, you have acceleration, not constant speed. And this is again a balanced force on the right here. The truck doesn't slide because of friction between the wheels and the ground. Balances the force of gravity. So in this